Okay, our task here is to sketch the following functions. Of course, we're not allowed to use the calculator. We want to identify the equations for the asymptotes. We want to find all the intercepts and then state the domain and range. So, let's start with our vertical and horizontal asymptotes. So, recall that to find a vertical asymptote, we said we're going to set the denominator equal to 0. Well, x minus 3 is my denominator. If I set that equal to 0 and solve, I have a VA at x equals 3. So over here at 3, I'm going to draw myself, I'm going to use a different color here, a dotted line to represent my vertical asymptote. I'll label that VA. Okay. For my horizontal asymptote, this particular function is bottom heavy, because if I were to put a million in for x, 4 divided by a million, who cares if there's a 3 next to it, it's still very, very large in the bottom. The result for y is going to be something that's very, very close to 0. So we have a horizontal asymptote at y equals 0. The equation is y equals 0, not x equals, it has to be y equals. Just like with the VA, it must be x equals, not y equals, because one is vertical, one's horizontal. So I suggest you use different colors if you have them. Okay, so we have our HA and our VA drawn. Those are our boundary lines. Recall that we said we're going to use those boundary lines 2 times. So the function will always approach them in 2 different spots. It would be helpful to find our intercepts. So let's do that next. Alright, we have x and then we have y. Recall to find a x-intercept, we're going to make y 0. And to find a y-intercept, we're going to make x 0. So let's find our x-intercepts first. So I'm going to throw 0 in for y. I have 4 over x minus 3. From there, if I put this over 0 and cross multiply, I get 4 equals 0. Well, wait a minute, 4 doesn't equal 0. Well, when you read between the lines, that means you don't have any x-intercepts. Okay, there's our symbol for the empty set. It means you don't have any answers to that. Doesn't mean you did something wrong. It means we're not going to have any. Which kind of makes sense since we have an HA at y equals 0. Next part here, we're going to plug in 0 where we see an x. So we're going to have y equals 4 over negative 3, which is the same as negative 1 and 1/3. Okay, so that is our y-intercept. So I'm going to go down here and plot my point. Now the word sketch means, doesn't have to be perfect, but you want to label key features, key points, such as VAs, HAs, and intercepts. So negative 1 and 1/3 is that key point that I'm labeling there. Okay? Well, that's enough information to know that our graph is going to go through this point. It's going to approach that, it's going to come through here. Okay? Notice I've used my HA over here on this side one time. I've used my vertical asymptote one time at the bottom. So the other part of it must be up here so that each asymptote gets used 2 times. And don't forget, it has to be a function. So I could not draw any part of my graph over in this region because then it would not be a function. Okay? Now, domain and range. That's the last thing that we need to find. So, my domain, my possible x values. Well, it looks like this function takes on all x values except for 0. So one way to say that is you could say that x is a member of the reals with the exception of 3. So, in other words, x could be any number except for 3. Or, if you prefer, negative infinity to 3 with a rounded parenthesis, and then 3 to infinity. So everything except for 3. And our range, very similar. Now we're talking about possible y values. If we look at our graph, it takes on all y values except for 0. So you can say y is a member of the reals, but y is not equal to 0. Or you can write it as negative infinity to 0, not including the 0, and then 0 to infinity. Okay? Let's move on to our next example. We have another rational function, and notice how we have this plus 4 on the end, which is our vertical shifter. Alright, we're going to be shifting things up 4. If we saw a minus 4, we'd be shifting down 4. So over here is where we will produce our sketch. Let's start with our, oh, there goes my dog again. Let's start with our vertical asymptotes. Set the denominator equal to 0 and solve. If we were to do that, we're going to have a VA at negative 1. So I have a VA at x equals negative 1. And my horizontal asymptote at y equals, well, this fraction is bottom heavy for the same reason we talked about in the previous problem. So that would suggest that the HA is at y equals 0. And it would be at y equals 0. However, there is a plus 4 on the end. That plus 4 on the end is going to shift it up 4. So I'm going to draw my dotted line here for my horizontal asymptote at y equals positive 4. Okay? Let's find our intercepts. So my x-intercepts I'll do first. I'm going to make y 0, so I have 0 equals 2 over x plus 1 plus 4. Well, if you subtract your 4 over, then you have negative 4 equals 2 over x plus 1, and you could then put this negative 4 over 1 and cross multiply. If we do that, we're going to have 2 is equal to negative 4x and then minus a 4. All right, when you distribute there, negative 4x minus 4. So I'm going to add over my 4, so I have 6 equals negative 4x. Divide by negative 4, so x would be 6 over negative 4, which is negative 3 over 2, which is negative 1.5. So that suggests that over here, negative 1.5, I'm going to have an x-intercept. So my VA was at x equals negative 1, so this will be slightly to the left of it. My y-intercept, try to find some room here. I'll do it over in this section. My y-intercept, so now I'm putting 0 in for x. If I do that, this is much easier to clean up. 2 divided by 1, that's just 2. Plus 4 is going to give me 6. Okay, so my y-intercept is 6. So let's recall that our HA is at y equals 4. So if my y-intercept is at the point 0, 6, it's going to be above my HA line. Okay? Well, that's enough information to guide us to then draw our function through those points. Keep in mind that each asymptote has to be used 2 times. Notice that if I focus on my VA, it's being used once, twice. If I focus on my HA, it's being used once, twice. Okay? Last one. So now, let's start by doing this. Let's focus on our vertical asymptote first. So recall, we're going to set the denominator equal to 0 and solve. If we do that, 3x equals 1, x would be 1/3. Alright, so if I were to spread this out a little bit, 1/3, I'll use a different color, it's going to be kind of hugging the y-axis. Okay, so here's my VA. The equation would be x equals 1/3. On your test, if I ask you a question that says find the equation of the VA, if you just tell me that the VA is at 1/3, you don't get full credit. It has to be x equals. Now, the HA. This is not top heavy, this is not bottom heavy. Instead, we have equal powers. each of these have a power of 1. So you have 2x raised to the power of 1, you have 3x raised to the power of 1. We're trying to figure out what's happening to y as x gets super big. Well, if x is getting super big, who cares about this minus 1 and this minus 1 top and bottom? If I were to plug in 5 billion for x, the x's would essentially cancel each other out, and you'd be left with the ratio of the coefficients. That is simply the numbers that you see in front. So y equals 2/3 would be the location of my HA. So 2/3, I'm going to draw that just inside that line. So here is my HA. Okay, we're not bothered by the fact that they're fractions. Okay, intercepts. Let's do that, and then we'll have an accurate idea to be able to produce a sketch. So the x-intercept, we are going to make y 0. So 0 equals 2x minus 1 over 3x minus 1. A lot of times people get confused, they're not sure how to solve. The moment I put this 0 over 1, people tend to remember what to do. So cross multiply. So 0 is equal to that top piece of 2x minus 1. You get 1 equals 2x, x equals 1/2. So this means we have 1/2 comma 0. Okay, so 1/2 comma 0 is my x-intercept. Now my VA was at 1/3. 1/2 is beyond that a little bit, so I'm going to put that to the right of my VA line. Okay, accuracy matters there. Okay, we know 1/2 is bigger than 1/3. Y-intercept, so we have y equals 2 times 0 minus 1 all over 3 times 0 minus 1. So that's going to give us -1 divided by -1, which is just 1. So 0 comma 1 is my y-intercept. Recall that the HA is at y equals 2/3. So 0, 1 is above that. So make sure you, and it's always wise to, if you don't have graph paper, you want to make sure you are labeling all of your values. So the VA is at x equals 1/3. The HA is at y equals 2/3. This root right here is 1/2 0. This intercept up here is 0 comma 1. So make it very clear. Okay. From there, we can produce our sketch. You know it's going to pass through the intercepts. It's bounded by these asymptote boundary lines. Notice what I drew passes the vertical line test. Okay. The domain for this last one here would be all x values except for 1/3. The range would be all y values except for 2/3. And the previous one, I forgot my domain and range. I'll just mention it with example 2. The domain would be all x values except for -1. The range would be all y values except for 4. Okay? So, that's it. Have a great weekend. Bye-bye.